topic of this video is determining the rate of interest or the time required to double or triple a lump sum of money. Let's look at a problem. How long does it take for an investment to triple in value if it is invested at 20% compounded continuously? Okay, so one of the most important things to understand about a problem like this one is when it comes to doubling or tripling your money, investment in an account is an act of multiplying. So let's say a bank is offering an account and two different customers both put money in that account. One person puts in $100, one person puts in $1 million. The length of time that it will take to triple, to multiply by 3, that $100 is the same length of time that it would take to triple or multiply by 3 that $1 million. So it takes the same amount of time to triple $100 as it takes to triple $1 million. And for that reason, you don't have to know how much money is being invested in order to determine how long it would take to triple. You can just make up a number. So we're going to make up a number in this problem. All right, so let's solve it. Here we go. The first thing we note about for this problem is that it is compounded continuously. That means we use the PERT formula. F equals PE to the RT. We're going to read the problem aloud, and every time we get to a value that tells us something for our variables, we'll write it down. How long does it take? So T is our variable. I'll write T equals question mark. For an investment to triple, that means we get to choose F and P. We'll say P, the amount of money in the present, is $100, and F, the amount of money in the future, is 3 times that, which is $300. If it is invested at 20%, that's R, 20%. Remember, the percent symbol is a mathematical constant. It always represents the same value, which is 0.01. So if you multiply 20 times 0.01, you get 0.20. All right, so, and then compounded continuously, E is a mathematical constant. We have everything we need. So let's plug in. F equals 300, P equals 100, E to the 0.20 times T. Okay, great. So we're trying to solve for T. The variable is up in the exponent, so we want to use the converter. The word log does not appear in our equation, so we use the exponent side. But we can only use the converter if we have exactly 3 things: a base, an exponent, and an argument. Nothing extra, nothing missing. In our problem, we have something extra, because the base is E, not 100E. If we wanted the base to be 100E, then both the E and the 100 would have to be in parentheses. Since there are no parentheses, that means that the base is just E. And for that reason, this 100 is extra. We've got a base, an exponent, an argument, and this is extra. To get rid of the extra, we divide. So divide both sides by 100. Then our new equation is going to be 3 equals E to the 0.20t. Notice the number 3 here showed up for a problem where it asked us to triple. This will always be the case. If you don't get a 3 here, then you've made a mistake. All right, now we have a base, an exponent, and an argument, so we can use our converter. The base is E, the exponent is 0.20t, the argument is 3. Matching up the colors and shapes, we get log base E of 3 equals 0.20t. All right, I've kind of run out of room over here, so I'm going to erase this. All right, let's continue solving our problem. So we've now converted from exponential to log form. So our new statement is log base E of 3 equals 0.20t. Of course, log base E is a natural log. So the natural log of 3 equals 0.20t. We want to get t by itself, so we divide. Remember, anytime you have a log, there is a brick. The brick contains the word log, the base, and the argument, and nothing outside the brick can affect anything inside the brick, except through the little gap in the upper right-hand corner if you happen to be using Rule 9, which we are not. So then, these 0.2's cancel, and we get t is exactly equal to the natural log of 3 divided by 0.2. Of course, that's not a very practical answer. We want to know how long it's going to take for our money to triple, I apologize. And so, we're going to use our calculators to get an actual value here. Start with the natural log of 3, hit the ln button on your calculator, then 3, then close off those parentheses. and then divide by 0.2 and hit enter, and you get the value 5.49. Now I am rounding here. The calculator actually says 5.4930614443. There were no rounding instructions in the problem, so I've just decided to round to 2 decimal places. The math learning software that you are using is going to tell you exactly how many decimal places that you want for this particular problem. And with that, we have determined exactly how long it's going to take in order to triple our investment. So whether that's turning $100 into $300, or whether that's turning $1 million into $3 million, it's still going to take 5.49 years.